watching Nama channel.
I will talk about algebra, a key mathematical topic. First, let us focus on the word algebra. What does it mean? Where does it come from? The word algebra has its origins in Baghdad, and this was many years ago. The word algebra comes from an Arabic book whose title is Al-Kitab Al-Muqtasir Fi Hisab Al-Jabr wa Al-Muqabla. This title is the source of the word algebra. So what does this title mean? The English translation of the title is The Book on Calculation by Completion and Balancing. Now let us look at a few more definitions. Algebra is putting real-life problems into equations and then solving them. That does not say much, does it? So let us take a simple real-world example. A clown was invited to perform at a birthday party. The clown arrived in the party with 18 balloons. On the way to the birthday party, 7 balloons got blown away. So how many balloons did the clown have in the beginning? Algebra helps us arrive at an answer. Let us see how. Let us denote this unknown number with an alphabet. You can use any alphabet, but a common one is the alphabet X. Now X gets reduced by 7, since 7 balloons were blown away. Let us write this down. After this happened, the clown was left with 18 balloons. So X minus 7 equals 18. What we have here is an equation with one unknown number. Using a bit of mathematical magic, we can now say X equals 18 plus 7, or X is equal to 25. 25 is the number of balloons the clown had in the beginning. Since this example is fresh in our minds, let us look at another definition of algebra. Algebra is about finding unknowns. It is the branch of mathematics that substitutes letters for numbers. Finally, algebra is the beginning of a journey that gives you the skills to solve more complex problems. So play with algebra and you will surely be rewarded. Thank you.
Before we see the types of terms, we need to understand the concept of the power of variables. Let's consider two different terms. The first term is 7xy and the second one is 17x cubed y squared. Observe the first term. It has two variables, x and y. What is the power of each of these variables? The power of x is 1 and the power of y as well is 1. Now look at the powers of variables of the second term. The power of x is 3 and the power of y is 2. Both these terms have the same variables, x and y, but the powers of each of the variables are different. Let's erase this and jump to the concept of the types of terms. There are two kinds of terms, like terms and unlike terms. What is the difference between them? Two terms are like if they have the same variables with the same powers. Don't worry, we will understand this with examples. When are they unlike then? Two terms are unlike if they have different variables or same variables with different powers. Let's zoom out and understand a couple of examples. Consider two terms, say 7xy and 15xy. Are these two terms like or unlike? Remember, to know the type, we just have to look at the variables and not the constants. Both these terms have the same variables, x and y. But that is not enough to tell us if they are like or unlike. The next thing we need to compare is the power of each variable. The powers of x are the same in each term, it's 1. And yes, the powers of y in each term is also 1. As both these conditions are satisfied, we can say that they are like terms. Same variables and same powers of each variable. What about 3x squared y and 3xy cubed? Are they like or unlike? Both the terms have the same variables x and y. Now let's compare the powers of each of the variables. Let's look at the power of x first. In the first term, it's 2, and in the second, it's 1. It's not the same. Even though the variables are the same, because the powers are not equal, these are unlike terms. Observe that we do not bother to check the powers of y in each case. Remember, if the powers of one of the variables is different, the terms become unlike. What about 8xyz and 8xy? The first term has 3 variables, x, y and z, and the second term has just x and y. It does not have z. Both the terms have different variables. Hence, they are unlike. Just remember these two things and you would have no problem understanding the types of terms.
Polynomials, definition and types. In this lesson, you will learn how to describe polynomials based on their number of terms and degree, and you'll learn the definitions of term, expression, polynomial, and degree. A term is a number, variable, or a combination of both. An expression consists of one or more terms. This expression has one term, this expression has 2 terms, and this one has 3 terms. To understand the definition of polynomial, it's helpful to break it down into its root word and prefix. The prefix poly means many, and the root word nomial can mean names or terms. In this case, it means terms. So putting it together, polynomial is many terms. So a polynomial is an expression with many terms. And here's an example. Each term in a polynomial is separated by a plus or minus sign. We can see them here. Once we identify all the plus and minus signs, we can clearly see the individual terms, such as the x squared, 4x, 3y, and 7. Polynomials can be described by the number of terms that it has. One type of polynomial is called a monomial. This word can be broken down into mono and nomial. The prefix mono means one and nomial means term. So monomial has one term, such as this example, 10x. A binomial can be broken down into bi and nomial. Bi meaning 2, nomial meaning terms, so a binomial has 2 terms. In this expression, the 2 terms are 3y and 2. A trinomial can be broken down into tri and nomial. The prefix tri means 3, nomial means terms, so a trinomial has 3 terms. In this polynomial, the 3 terms are x, 7y, and 5. Some polynomials have more than 3 terms. If there are more than 3 terms, we can just call it a polynomial. Now it's your turn to practice. Describe each polynomial based on the number of terms. And if you need more time, you can pause the video. The polynomial in A is a binomial. It has 2 terms. In B, there's just 1 term, so it's a monomial. And in C, there's 3 terms, so this is a trinomial. In D, there are 4 terms, so we can just call it a polynomial. Polynomials can also be described by their degree. The degree of a polynomial is determined by the highest exponent that is with a variable. So in this example, the first and second terms both have the variable x. However, the variable x in the first term has an exponent of 2, and the x in the second term doesn't have a variable at all. So the highest exponent is 2, and we would say this polynomial has a degree of 2. Here are some other types of polynomials based on their degree. We already saw this example where the highest exponent is 2, so we say it has a degree number of 2, but we can also say that this is a quadratic expression. And this one, both terms have an exponent, but the highest exponent is 3. So it has a degree number of 3, and we say that it's cubic. In this expression, the variable x doesn't have an exponent written with it, but it's implied that there is a 1 there. So we would say that this has a degree of 1, and we call it linear. If it's just a number, like with this number 12, there's no variable at all, so we say it has a degree of 0, and we call it a constant. Now it's your turn to practice. Describe each polynomial based on its degree number and name. And if you need more time, you can pause the video. The first expression in A has a degree of 1, so it's linear. There's no exponent written with the variable x, so we have that invisible 1 there. In B, it's just the number -15. There's no variable at all, so it has a degree of 0, and we call it a constant. In C, the highest exponent is 2, and we call it a quadratic. D has the highest exponent of 3, and we call it cubic.
Welcome to the lesson on Algebraic Identities. At the end of this lesson, you will be able to define algebraic identities, state standard algebraic identities, and apply standard algebraic identities to solve problems. Let us consider two algebraic expressions. We will combine both the algebraic expressions with an equal to sign. Now let us see. Are two algebraic expressions really equal to each other? Let us check the value of algebraic expressions in LHS and RHS for value of an A equal to 4. Upon putting value of A equal to 4 in LHS, we get 7. Upon putting value of A equal to 4 in RHS, we get 7. Hence, LHS equals to RHS for value of A equal to 4. Let us check these expressions for any other value. Say A equals to 1. We find that LHS equals -8. Upon putting value of A in RHS, we again get -8. Hence, LHS equals to RHS for value of A equal to 1. In fact, for any value of A, this equation will have LHS equal to RHS. Hence, this equation is an identity. An equation that is true for all values of the variables in it is called an identity. Let us take another example and check if it is an identity. Substituting value of A equals to 2. We find that LHS equals to 4 and RHS equals to -1. Hence, LHS is not equal to RHS. Substituting value of A equals to -2. We find that LHS equals to 4 and RHS equals to -5. Hence, LHS is not equal to RHS. Hence, this equation is not an identity. There are some identities which are used frequently. Such frequently used identities are called standard identities. Let us check our first standard identity. It states that a plus b whole square equals a square plus 2ab plus b square. A plus b whole square can be written as a plus b multiplied by itself. Upon further simplification, it can be written as a multiplied by a plus b multiplied by a plus b. Solving further, we get a square plus 2ab plus b square. Similarly, a minus b whole square can be written as a minus b multiplied by itself. Upon simplification, we get a square minus 2ab plus b square. Product of a plus b and a minus b can be simplified as a multiplied by a minus b plus b multiplied by a minus b. Upon further simplification, we get a square minus b square. The next standard identity is product of x plus a and x plus b is equal to x square plus x times a plus b plus ab. Rahul is puzzled as to how to find the square of 4.9. Let us help him out. 4.9 square can be written as 5.0 minus 0.1 whole square. Let a equals 5.0 and b equals 0.1. Upon applying standard identity, a minus b whole square equals a square minus 2ab plus b square. When we put the value of a and b, we get 24.01 upon solving. Find 985 square minus 15 square. We will use standard identity. A square minus b square equals to a plus b multiplied by a minus b. Let a equals 985 and b equals to 15. Upon applying these values and solving, we get the result as shown. Find 501 multiplied by 502. We will use standard identity x plus a multiplied by x plus b equals to x square plus x times a plus b plus ab. Here, x equals 500, a equals 1 and b equals 2. Upon applying these values and solving, we get the result as shown. At the end of this lesson, you are able to define algebraic identities, state standard algebraic identities, and apply standard algebraic identities to solve problems.
Thank you for watching நம்ம சேனல். இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்ததுன்னா லைக் பண்ணுங்க, கமெண்ட் பண்ணுங்க, ஷேர் பண்ணுங்க. வீடியோ அடிக்கடி பார்க்கறதுக்காக இந்த சேனலை சப்ஸ்கிரைப் பண்ணிட்டு மறக்காம பக்கத்துல இருக்கக்கூடிய பெல் ஐகானை